Hi viewers, I am T. Ramesh, Assistant Professor, Department of Mathematics, Dr. SNS Rajalakshmi College of Arts and Science. In this lecture series video, we are going to discuss about a queuing theory concept, analyzing an M1 model. There are two problems discussing in this case. The first problem, calculating expected queue length in M1 system. The presentation explains how to calculate expected queue length in a simple MM1 queuing system. So here we learn step-by-step calculations using arrival and service rates. So understanding what is MM1 model. First, what's the meaning of single server? Single server means one server handles all customers sequentially. The next was what is Poisson arrival? Customers arrive randomly at an average rate lambda that is equal to 8 per hour. What is exponential service? The service time are exponentially distributed with rate mu. So convert mean service time to service rate. So what is mean service time? 3 minutes per customer. So convert this mean service time to service rate mu. The customer served per hour, that is 60 minutes per hour. So 60 divided by then the customers, that is 3 minutes divided by 3. So 60 by 3 is equal to 20. So recall arrival rate. So arrival rate, customers arrive at 8 per hour, that is lambda is equal to 8, and service rate mu, service rate is 20 customers per hour. So now formula for expected queue length, that is LQ, length of the queue. In MM1 queue formula, length of the queue is lambda square divided by mu into mu minus lambda. So variables lambda, so the arrival rate, that is customers per hour, and mu service rate, that is customers per hour. So plugging values into the formula. First step 1, we take 8 square is 64, and step 2, calculate the denominator, that is we need mu into lambda minus mu, that is 20 into 20 minus 8, that is 20 into 12, that is 240. Step 3, divide numerator by denominator, that is 64 divided by 240 is equal to 0.267. So interpretations of results, expected queue length is the 0.267 customers waiting on average. So system efficiency, low queue length indicates high service efficiency. Implications, most arrivals experience little to no waiting. So what we learned here, identify the model, confirm the system fits MM1 assumptions, and calculating rates, convert the time to arrival and service rates lambda to mu. Apply the formula, that is length of the queue is lambda square is equal to lambda square divided by mu into mu minus 1 to find the expected length of the queue, and validate, interpret the results to improve system design. Next we go to the second problem, analyzing an MM1 model, problem 2. So in this presentation it's focus MM1 sequencing model characterized by Poisson arrivals and exponential service time. The scenario involves a service center with a mean arrival rate 3 minutes per hour and a mean service rate time of 10 minutes. Our objective is to determine 3 crucial performance matrices: the utilization factor, the probability that exactly 2 units are present in the system, and the expected number of units in waiting the queue. Understanding these metrics is essential for effective resources allocations and to ensuring smooth service operations in context models by queuing theory. So calculating utilization factor. So utilization factor denote rho, It represents the proportions of time the service facility is busy. That means the arrival rate is lambda and the service rate is mu. Therefore, the utilization factor rho is equal to is lambda by mu. And the next given data, so mean arrival rate is lambda is equal to 3 units per hour. Mean service time is equal to 10 minutes. That means 1 by 6 per hour. Service rate mu is equal to 1 per mean service time, and that is equal to convert everything as to 6 units per hour. So computations rho is lambda by mu. That means lambda is 3 and mu is 6. So 3 by 6 is equal to 0.5. This means the service center is busy 50% of time, indicating moderate utilizations and a capacity to handle incoming units. So probability of exactly 2 units in the system, that is P2. We apply the formula for suppose the probability for n customers in the system is Pn. That means rho power n into 1 minus rho. Here there are exactly 2 units in the system, therefore n is equal to 2. Apply n is equal to 2, so P2 is equal to 1 minus, already we discussed what is the value of rho is 0.5, therefore 1 minus 0.5 into 0.5 power 2. After reduce that we get this value, that is 0.125. So interpretations, the probability that exactly 2 units occupy the system both in service and in queue is 12.5. So expected number of units in the queue, that is the length of the queue. So mean number in the system, that is L is rho divided by 1 minus rho. Okay, so that is 0.5 divided by 1 minus 0.5, that becomes 0.5 divided by 0.5 is equal to 1 unit. So mean number of service, length of the system, that is utilizations rho, already we have this, is 0.5 units on average. So calculating queue length, that is length of the queue, that is LQ is equal to L minus LS, that is length divided by length of the system. That is equal to 1 minus length of system is 0.5, so 0.5 units. So we calculate all these things. So that this means on average there are 0.5 units waiting in the queue, indicating minimal concessions under current conditions. So arrival and service process assumptions, Poisson arrival process, assumptions arrivals are random and it is memoryless, occurring independently over time. Exponential service time is at times service durations follows an exponential distributions, implying the probability of completions in independent of elapsed time. So implications of this assumptions justify the MM1 model, a standard in queuing theory for single server system experiencing random traffic. So significance of utilizations in a system design, capacity planning, utilization indicates whether the facility is over or underused. Service quality, high utilizations can lead to long queue and delays, affecting customer satisfactions. So what is interpretations of all these things? The queue length quantifies concessions. Longer queues implies worse service delays. Probability of units presence, that is PN, the helps predict system occupancy and inform staffing decisions. Waiting time links, expected queue length correction correlates directly with the customer's wait times. Thank you.